The cosmos is a tapestry of wonders, constantly revealing secrets that challenge our understanding of existence. Recently, astronomers have unveiled a truly unprecedented cosmic phenomenon. They've discovered a bizarre galaxy, now dubbed the Infinity Galaxy, that could fundamentally redefine our theories about black holes. This groundbreaking find comes from a team led by Yale astronomer Peter Van Dokkum. What makes the Infinity Galaxy so extraordinary is its origin. It's not a single entity, but rather two galaxies that have recently collided and are in the process of merging. Their cosmic embrace has sculpted them into a form eerily reminiscent of the mathematical infinity symbol. But the biggest surprise lies at its very core. Researchers have reported the presence of a supermassive black hole nestled within a dense cloud of gas. This discovery is remarkable for several profound reasons. It may unveil a completely new mechanism for how black holes form. It also offers crucial insights into how such colossal black holes could have emerged so early in the universe's history. Most excitingly, this could be the very first direct observation of a supermassive black hole shortly after its birth. As Van Dokkum himself put it, this is as close to a smoking gun as we're likely ever going to get. Everything about this galaxy, he notes, is highly unusual. Beyond its strange appearance, the black hole itself is actively consuming a vast amount of material. The most astounding revelation was the black hole's exact position. It was not found within the nuclei of either of the two merging galaxies. Instead, it was situated right in the middle, between them. This observation challenges conventional understanding and prompted researchers to ask, how can we make sense of this? The discovery emerged from studying images from the Cosmos Web survey. This vast collection of data is part of the archives of NASA's James Webb Space Telescope. Further observations were also carried out using the W.M. Keck Observatory. Archival data from the National Radio Astronomy Observatory's Very Large Array and the Chandra X-ray Observatory also contributed. The black hole discovered in the Infinity Galaxy is colossal, about 1 million times the mass of our Sun. That's an astonishing 300 billion times the mass of Earth. Finding a black hole outside a galaxy's nucleus is already unusual. But to then discover that this black hole had only just formed was truly unprecedented. This finding directly impacts the ongoing debate about how black holes formed in the early universe. One theory, known as the light seeds theory, suggests that small black holes form from collapsing star cores. These light seed black holes would then merge over vast timescales to become supermassive. However, the Webb telescope has already spotted supermassive black holes that appeared too early in the universe to be explained by this slow growth model. This leads us to the heavy seeds theory, championed by astrophysicist Priyamvada Natarajan and others. This theory proposes that much larger black holes can form directly from the collapse of enormous clouds of gas. The main challenge for the heavy seeds theory has always been that collapsing gas clouds typically form stars, not black holes. But the Infinity Galaxy might offer the missing link. It demonstrates how extreme conditions, akin to those in the early universe, could bypass star formation and lead directly to a black hole. In this specific case, two disk galaxies collided, creating the stunning ring structures of stars we observe. During this violent collision, the gas within these two galaxies experienced immense shock and compression. This extreme compression might have been just enough to form a dense knot of material.
A knot that then collapsed directly into a black hole.
While such galactic collisions are rare events in the present universe,
similarly extreme gas densities are believed to have been quite common during early cosmic epochs.
this was a time when galaxies were just beginning their formation.
The infinity galaxy acts as a living fossil, offering a window into those formative cosmic years. However, Van Dockum and his colleagues emphasize that additional research is crucial.
More observations are needed to fully confirm these groundbreaking findings, and to fully understand what they portend for the vast mystery of black hole formation. This discovery reminds us that the universe is far stranger and more wonderful than we could imagine, and that our quest for knowledge will forever lead us to new frontiers.